Hi everybody, I'm Carson Cole and this is my informative summary of how to train a robot using AI and supercomputers. This is an article from Daily Science. Okay, so a little bit about me before we start and what my qualifications are in regards to this article. So basically, I'm a sophomore at Wayne State University. I'm majoring in electrical engineering currently, so I'm taking classes that deal with the issues that are present in this article, and yeah, so that's about me. And so, what are we going to talk about today? So, basically, what we're going to talk about today is four different topics in this article. So, starting off with a little bit of background information on William Besky, he's the head of the operation training these robots. The different types of training that they'll be using, which are basically visual capture, and then there is GANs, which you'll learn about later. Creating different environments, and then how the virtual training environments created issues for them and how they overcame these issues. So a little bit about William Besky. He is a assistant professor and he's a researcher at the University of Texas at Austin, and he's interested in training robots. Where did he get this interest in training robots? Basically, he interned at iRobot when they were creating the first version of the Roomba. So he wanted to create a better version of this. He basically wanted the robot to be able to move around and adapt to its environments, completely autonomous from a human being controlling it. So he looked into the different types of trainings to begin with. Him and his group of six PhD computer scientists recalled a method that Roomba used, which was visual capture, where they used a 360-degree camera and captured the environment. Very slow process. It was a very slow process, and the software they used was very expensive. He did not have access to this, although the university supplied them everything that they basically needed. So they switched the focus to GAN's training method, a generative adversarial network. So basically what this is a discriminator and a generator. A generator generates the environment, and a discriminator tries to tell what the different type of images are. So they work against each other and try to make different environments and adapt to them. So this technique is very fast compared to visual capture and very less expensive. So the university liked that, and they moved forward with this and used their supercomputer Maverick 2 to create these environments. So creating these different environments was very time consuming, even with the GANs. So they said, we got to look for a better way to do this. Instead of using full 3D images, they used 3D point clouds, which is the surface basically of the image made out of 3D points, and this allowed them to create images much quicker and easier than they did before. And they're also able to build up the complexity of images as they go, so the robots can discriminate more easily as time goes on. So the main issues that they faced with this was they were not able to quantify the invisible variables and forces such as gravity, friction, and other forces that you can't see, but they're still there. So they need to be able to account for these and adapt to them. So Besky thought of a program called Sim2Real. Sim2Real is it's a program to quantify these experiences and forces, and especially because these robots are training in virtual environments, they don't even experience those at all. So he wanted to create a program to overcome the reason or the fact that they don't experience those forces. And that was basically the end of the article. So in conclusion, the group of researchers wanted to train these robots using GANs, generative adversarial networks, two artificial neural networks working against each other, two computer brains. They ran into issues with the generation of images, but were able to overcome that with the clouds, which were much faster to produce. And then lastly, they were able to figure out how these different environments to make them more realistic with Sim2Real and really make the invisible forces quantified and available. So we're still very far away from fully autonomous robots, but we are one step closer. Okay, that's my end of my presentation. Thank you.